In this video, we will be first talking about 2D elastic collision, and after that, we will be coding it in Matlab. So, let's consider there is a 2D space, xy, scared space. There are two particles of mass m1, m2. Let's consider particle 1 is moving in x direction with velocity v1, and particle 2 is at rest with velocity v2 is equal to 0. And after collision, let's suppose particle of mass m1 reflects and moves in a direction making an angle of theta 1 with x direction, and particle of mass m2 making an angle of theta 2 dash with the x-axis. So we know in order to solve a collision problem, we have to conserve two things: momentum and kinetic energy. Since momentum is a vector quantity, we can conserve it in x direction and y direction. As far as kinetic energy is considered, it's a scalar quantity and it will have only one equation. So number of equation we have is equal to 1, 2 equation and 3 equations. So number of equation we have 3. So let's see how many unknowns we have. We have got number of unknowns as v1 dash after the collision, v2 dash after the collision, theta 1 dash after the collision, and theta 2 dash after the collision. So we have 4 unknowns. So in order to solve these 4 unknowns, it's prerequisite that we know one of these unknowns. So usually we can take theta 1 known or theta 1 dash known or theta 2 dash known. So let's write number of equations that are present. First of all, momentum in y direction will be considering. Momentum in y direction should be conserved. So momentum before the collision is not a momentum after the collision. So p particle 1 moment, p1 moment of first particle in y direction plus second particle moment in y direction is equal to particle 1 moment in y direction after the collision, moment of particle 2 in y direction after the collision, so which will be given by m1 v1 y direction, but velocity of particle 1 in one direction is 0, y direction is 0. So this would be, because it's moving in only x direction, there is no y coordinate there, so this will be 0 before the collision. After the collision is also for particle 2, it's 0. As far as particle after the collision, it would be given by, it will be like both of them will be positive in upward direction, so it will be given by m1 v1 dash sine of theta 1 dash plus m2 v2 second particle sine of theta 2 dash. This is first equation. So we can rearrange this in order to solve analytically. So we can go for m1 v1 dash sine of theta 1 dash is equal to m2 v2 dash sine of theta 2 dash. Okay, now conserving the momentum in x direction, momentum in minus here in x direction. Okay, so p1 moment 1 in x direction before the collision, and likewise particle 1 in x direction after the collision, particle 2 in x direction after the collision. So particle 1 is moving in x direction with velocity v1, so it will be like m1 v1, particle 2 it's 0, it's at rest. As after the collision, it will be like m1 v1 cos of v1 dash cos of theta 1 dash plus m2 for particle 2 m2 v2 dash cos of theta 2 dash. This is the second equation. And as far as kinetic energy is considered, consideration of kinetic energy, so that would be given by half of m1 v1 square plus half of m2 v2 square, and after the collision f1 v1 dash ka whole square plus m2 v2 dash ka whole square. V, this is 0. It has nothing to do with this one because there's no velocity for particle before the collision. The rest would be same, so this can be cut out and 0 can be written here. This is 3 equation. First, we will be actually creating a function to solve for unknowns. Okay, let's create a function. So how to solve these type of nonlinear equation in 3 variable? That is a good question. So first of all, I have to create, there's 2 ways, symbolic way and another is like analytical way. We're gonna do the symbolic one. We're gonna create symbols. v1 dash, that is an unknown, v2 dash is the second unknown, and theta 1 dash will keep it unknown and theta 2 will be known. So a function would be like what we are interested in. We are interested in this one, v1 v2 dash theta dash. Yes, okay, we can actually change that later on. So thing we are interested in is like v1 dash comma v2 dash theta 1 dash and comma, let's say theta 2 also, we can give it here back. What do we do? Again, can give it back, just create a generalized one. But we did equation dependent, so it would be better to write a general equation. Yep. So we name it collision 2D, and input would be m1 comma m2 comma v1 comma v2 comma theta 1 comma theta 2. These are the nodes. We'll put brackets, this matrix. Why am I doing that thing? I will tell you exactly, because I can't just use too many variables in there. So I can, in main function, I can use these things. So I'm going to copy paste the node function I have already created. Structured particle, this was the last one we revised. Is it this one? Nope, it's not this one. I think that I created. Okay, let's see later on. This control X. I'll find it later on. What was the thing? Just created coord. Name it this one. Then I need this variable. Then I need those variables. And then theta 2 dash would be given theta 2 dash. Okay. One given, and these are the things that won't be given. Okay. Let's create an equations. Equation 1. Let me open my this and see the equations. We do the equations. Okay, here for the equations. So equation 1 is like m1 v1 sine theta. So let me seeing if it's working. Let me create again. Coord is equal to m1. Let's keep it 5 comma 5 comma v1 5 v2 0 comma theta 1. That would be 0. We can use actually directional cosine as well, because directional cosine in general function is there. Okay, that would be cool. We can go for directional cosine. We can see later. First of all, we'll see if it's soluble or not. Theta 2, that is also 0, and we can go for theta 2. Why not put it there? Fourth, theta 2 dash. Okay, let's put it equivalent to, let's say after the collision it's 30 degree. Let me comment this out. Okay, yep. So whether it is called, yeah, I'm gonna use it like that. So equation 1 was m1 v1 sine of theta 1 is equal to this one. So create equation eq1 is equal to m1, that is Sims, not Sims, coordinate, chord. I should write something simple. Cool, let's call it CRD. CRD, it's first one, CRD1, and we can go for m1 v1 dash into v1 dash into sine of theta 1 dash. Sine d, it means in degrees. Sine is in radical, sine d is in degrees. Theta 1 dash plus CRD m2 2 m2 v2 dash into sine degree theta, not theta 2. Now I'm gonna say CRD, last one, 1 2 3 4 5 6 7. Okay, CRD 7 is equivalent to 0. That's equation 1. Now write equation 2 would be m1 v1 dash m1 v1 dash cos of theta 1 m2 v2 dash cos of theta 2 dash. Okay, just copy paste this one, control C, control v1 dash sine cable, in place of sine this is cos, this is sine, this is cos. Okay, CRE2 m2 is equal to m1 v1, so CRD m1 into v1. v1 is actually CRD 3, okay, into, if it is some sine, this means some angle, you can go for sine of, so we have to keep 0 degree, 0 0. Okay, sine of theta 1 is, okay, 2 3, fifth one it is CRD 5. If there is sine as well or it's 0, we can actually put a generalized one. We can just write it again, the same thing, control C, control V, CRD 1, this time 2, CRD V2, M2 V2, 6. Okay, this is equation 2. Equation 3 is given as, where is it there? So it's like 0.5 into CRE M1 and v1 dash v1 dash whole square, okay, plus 0.5. Let's hold this for example fail CRD 2m2 into v2 dash whole square, not this dash, okay, is equivalent to 0.5 m1 unit square into CRD1 into v1 का whole square CRD 3 का whole square plus the same thing 0.5 into CRD 2 into CRD 4 whole square. So this will be exact. Okay, in order to solve this equation, we just have to write three unknowns. V1, I should have write something else other than V1 dash. Okay, V2 dash, comma, theta 1 dash, solve, okay, equation. So I have to make an equation of all these equations is equal to equation 1 eq1 comma eq2 comma eq3 eqn. Now with variable I can write these are the variable there. Okay, is there anything else we need? Real return, let's see. Let's start it. Let's wait. Okay, it has even two values. Of course, there are two values. So we have v1, v2, so either you will go to 30. So if this is going to 30, he's saying this will also move to 30. 1 minus 150 is like opposite of 1 minus 150. Okay, I think this is good. Okay, minus 5 is plus minus. I can't just take every answer. I have to take one of these things. It can't go in positive, it has to go in different direction. But mass is same, yep, mass is same. And I have to actually convert, maybe I have to convert this thing, let's see. Okay, variable 1, I need 4 variables. Okay, I can't just put it in sim function, I have to go something else. Let's see v1 dash, let me convert it into int 64, not int 64, but we're converting to int double. Let's see if it can be converted, because as this is in different form, we have to convert it into different. I think it can be converted. Yes, it can be converted. And the thing we can take from this one, so I can say that there are 3 outputs. I will name it out. 1 is equal to v1 dash, and it's 2, and convert it into double. Why am I doing this thing? Okay, why am I doing this one? This was good. Okay, I can do it same way. Control C, Control V, again Control V, out 2, out 3, V2 dash 2, theta dash 2, and in here I would write a function of out t. Okay, no, I shouldn't have written that thing. Okay, it doesn't matter. It doesn't matter. So yeah, for control y, not count one. I have to go for count. Okay, so here I can write out is equal to out 1 comma out 2 comma out 3 comma theta 2 dash theta 1 dash in here. I don't need to write this much here then. Okay, let's run it. Okay, let's close the output there. Something, what is happening? Uncons function variable theta 2 dash. Okay, it's not theta 2 dash, it's actually CRD 7. So okay, let's see the first component what we have solved. Okay, 3 minus 1. Okay, this one is not actually good. Let's see the fourth one. We want p1 to be okay positive, but p1 to be positive, v1 to be positive. Just the cos of theta should be negative, so we just need theta changing. Rest the magnitude can remain positive. Okay, I think 4 is good. Okay, I think this video is getting too large. Maybe we can continue in next video. After this, we're gonna go for generalized code that we have already created in a revision lecture. It's the same code, we will be doing some change to it and moving forward from this code onwards. If you haven't watched that revision state video, you have to watch it in order to understand what's going to happen after this. Thank you that